Hello everybody, how are you all doing? I'm going to be traveling this month, so there won't be too many videos, but I'm just making two quickies to see us through February, and then we'll have to see if I can make something on the road. My other channel is stopped into March, but this one is probably not going to be updated as often. Okay, so YAB is perfectly capable of showing a graphic image. Anything that the Haiku translator system can handle. Problem is, you have to know exactly where on the disk it is. And maybe your user has moved things, and maybe, all sorts of things can happen. And it's also, I don't know, I'm probably alone in this, but I just like to have my programs as one file. You run that file and everything works. So how can we incorporate a graphic, which is a binary file, into our program? Well, all you need is a graphics format that is not binary, and one exists. It's called PPM. It's a very old graphics format, but it can be expressed in pure ASCII. Now, technically, PPM is a black and white format, and if you add color to that, it should be called PBM, right? But we haven't quite got that going. So the first thing you need to do, and let's see, where is it? Data translations. You have to go to PBM images, and you have to enable write ASCII. And that will mean that your PPM images will be slightly bigger, but, it's not the end of the world. Then you'll see that there are a lot of different choices here, and I'm afraid you'll just have to experiment a little bit, see which ones work best for you. Right? I have settled on system palette 8 bits. Okay, but this write ASCII, that is the most important bit for us here. And when you enable that, it's not enabled by default. Any PPM file that you create will be a pure ASCII file. I'll show you now. Okay, and then you close that down and it'll become active. Okay, so this thing here, 2p notes, that's a PNG file. That's a binary file, right? So call it up and you save as, and you select PPM. And you give it a name, and I've already saved it up here. Now, the first thing we see is that PPM does not have the concept of transparency, which is a bit of a bummer because everything turns black. So if that's important to you, then you may want to, just massage this file so that it becomes one with the background that you're going to use. I've done one here and converted it to PPM. And the standard gray background that Haiku uses all over the place. The RGB values are 219, 219, 219. However, this is the one that I created and that I wrote into my program. Now, first things first, let's have a look at that. And you see, there's nothing special about this. This is pure ASCII. And you'll be able to write that into your program. How do you do that? Well, let's have a look at this program. All right, so all I've done is I've taken that file and I've put it into data statements. And here is a little note that's saying the data ends now. And so if we look at the rest of the program, right, first we use this line here to find where does Haiku store temporary files. Right, and this is actually the approved way of doing it, because in the history of Haiku that has changed. At the moment it is in, let's see, boot system cache TMP, right? But it used to be somewhere else. And there's also some link from that to /TMP. But those things can change. This will always get you the currently approved. So even in 10 years' time, if the developers of Haiku have decided we're going to move that around, it's not going to be here anymore, this program will find wherever it's supposed to be. Problem is that this thing gives us the result and there's a line feed at the end of it. So here are a few lines in which I simply remove that line feed because I want to stick something at the back of it, which I do here. And here is, this is where I'm going to write my reconstructed PPM. Right, and so we restore picture, and which means go to this label picture. All right, then we've got a little repeat until file loop there. Right, read a string, in other words, read a line of data, and then print it to channel 1, which is this file in the temporary. Right, and so now we can know exactly where this thing is, and therefore we can just paste it into our little program. Right, and if you want to see how, see it in more detail and take your time, it'll be up on the Git repository. See the show notes. And we have the shortest main loop in history, which just keeps the thing on the screen until you close it. Okay. And then once we have drawn this thing, we just, do the right thing and remove it. We can always reconstitute it again. Now obviously this is going to work best with very small pictures, you know, like this little icon here. You've got a 4K picture, reconstructing it is going to take a little while. I've got a different method for that, which we'll talk about next lesson. Okay, so if we now run this program, there we go. So it took all these data statements, recreated this ppm in the temporary directory, and says, I know exactly where my file is, and I'm going to show it. And that's really all there is to it. So there is already one way to take a binary file with you in your code. See, and there are other ways to do this. You could try UU decode. There are other, utilities to turn a binary file into a piece of ASCII that YAB can handle. Alright, in another program that I once wrote, I had all those data points, and there I actually didn't even bother to recreate the file. I just drew it one dot at a time, from the data, and that was a bit more intensive, shall we say. Okay, so that's it for today, and next lesson I'm going to show you a completely different way of doing things, which does not involve transforming your binary code into ASCII. See you then.